All right, people, I'm going to be finishing up 8.2 for you. 8.2, there must have been a few questions that you had or something that you were wondering. And also there are some applications that I want to talk about with the operations of matrices. So let's look at number 29. A is a 2 by 2 matrix. It's a 3, negative 1, 1, 3. What if I asked you to calculate, hey, what's A squared? So what's squared of A for this matrix 2 by 2? Now, what if I were to tell you a true story? One time, a student actually did this. Is he or she correct? And if not, what did he or she do wrong? Can you figure that out? Okay, I hope you don't make this mistake. This is definitely incorrect, right? Looks like the student squared each of these elements, which is a no-no, right? How should he have attacked it? So we're going to say, of course, you would do this, right? And you would have to do the actual dot matrix. So 3 times 3, negative 1 times 1, negative 1 times 1, and 3 times 3. So did you guys get something? And what if I asked you to do A cubed? Same thing. You'd have to multiply this 3 times, right? So hopefully you'll get another 2 by 2 matrix and see if you get 9, negative 1. So it's 8, right? Negative 3, negative 3. So that's negative 6. Sorry, negative 3, negative 3. That's negative 6. 3, 1. Sorry, 3, 3, 6. Okay, and negative 1, 9. Negative 1 plus 9, which is 8. This is what this student should have got. So it's a little bit weird, but A squared does not look anything like this A squared that this student did, okay? So be careful with that. Make sure you write it all out, okay? I hope you don't make the same mistake. Also, I wanted to ask you, do you think that AB is going to equal B times A? Okay? And I'm going to tell you that multiplication in matrix is not commutative, therefore AB is not equal to B times A. Only a special case, and we're going to discuss that next section, okay? Let's move on to an application problem, okay? Actually, before we move on to that, yeah, I think you might have seen this kind of weird situation on your homework yesterday. Also, can I show you the properties of the multiplying matrices and the identity matrix? So identity matrix is going to be part of your vocab for chapter 8, identity matrix. So remember what identity property is for multiplying or addition. For addition, you're adding nothing, so you get yourself back. So it's 0, but for multiplication, you have to multiply by 1 in order for you to get yourself back. So I'm going to show you some properties. You don't need to write them all down because more or less you should know these. Let A, B, C be matrices, let A, B, C be matrices, and let C be scalar. So take a look at these. Yeah, and you have to be able to identify these properties on your vocab test, okay? But I think more or less you know these definitions. Let's move on to identity. Identity is super important. Identity matrix is defined by I sub n. This n tells you the actual dimension. An identity matrix is only valid for a square matrix. And a square matrix, I don't know if we talked about it last class, is an n by n matrix always. And identity matrix only exists for a square matrix, okay? So it looks kind of like this. What do you notice about an identity matrix? I hope you notice it's all zeros everywhere else except for the main diagonal. Okay, main diagonal. So how about an identity matrix of a 2? That would mean 1, 0, 0, 1. How about I3, identity matrix of a 3 by 3 matrix? It's everywhere zeros except for the main diagonal. Okay, etc. That's an identity matrix. Now, if you multiply any matrix with an identity, you're going to get yourself back. It has to be a square matrix, though, okay? All right, let's move on to this problem that you might have seen on your homework last night. You can write any system of equations AXB like this. So let's say we have a linear system here, okay? And I know you thought it was really weird yesterday. Why are we doing this? And honestly, it's not going to make sense until you get to 8.3. So I think it's a little bit weird that your textbook included this in 8.2. But it's nice to know. You remember the coefficient matrix? So we're going to take the coefficients of this linear system. Okay, that's negative 2, 4, negative 3, 2. And that's actually your A matrix. Now, I'm going to surprise you with the X matrix later. But what about the B matrix? The B matrix is actually the constants, negative 6, 20. This means when you multiply this 2 by 2 A matrix with this X, then you get this B. So what is this X? Well, it has to look like the linear system when you multiply this and this. So it's going to be X and Y, a 2 by 1 matrix. So let's try it. Negative 2X, negative 3Y. So there is that, equals negative 6. 4x plus 2y is equal to 20, and that's how this should look. This is the setup, but for now, don't worry about how to solve this using this or anything like that. Just know how to convert from here to here, but this is not even going to show up on your quiz for 81282. Okay, so this is a really cool thing, and we're going to use cool little methods later. Okay, all right, so don't worry about that too much. I know you were a little bit stressed probably. Let's move on to the last part. Now, let's say we have this situational problem, okay? This is still 8.2, and this is the application. It's a really cool application, actually. Let's say, so I was going to do something fun in class with you. We were going to make babies with these two lovers from the class. So let's say, let's just say Kelly, in this case, and Anthony become lovers and have a baby. And our baby would be named, let's see, what would it be named? Let's name it Tony, okay? Tony. Now, Tony is going to own a fruit farm, and he's going to raise 2 exotic fruits, which will be shipped out to 3 countries. The number of units of fruit I that are shipped to country J is represented by the Aij in the matrix, this guy here. And the profit per unit is represented by this matrix here. Now, right now, all I want you to do is study the matrix A and study matrix B. What is this telling me? What do the columns tell me? What do the rows tell me? What does this B? There's 2 of these prices, right? So what does that tell me? Now, what does also the product of BA tell me? What does the product of AB tell me, if anything? Are they significant when I multiply? And how are they significant? And this is a really cool application of a matrix. Okay, so we're going to try this together. Now, have you figured out what each of the columns, should I read it by rows or should I read this by columns? What does the 100 stand for? What does the 75 stand for? Make sure you relate that to the actual situation. So it says we have 3 countries and 2 exotic fruits. So I hope you were thinking, oh, these columns represent each country, and these rows represent the fruit. So there's these 2 exotic fruits that are produced by each of these countries, I, J. That's why it's A, I, J. And what happens when I multiply A times B or B times A? If it's significant at all. Sometimes when I multiply them together, it's not significant at all. But when I multiply correctly, it is significant. So we're going to study that data. Now, this says $3.75, this says $7. So that must be the 2 fruits and how they yield, what the profit that they yield. Okay, so in this situation, this is a 2 by 3 matrix. This is a 1 by 2 matrix. There's only one way I can multiply it. But if it's not the case, you have to actually consider which way should I multiply and why. And you have to be able to defend that. So in this case, I'm going to multiply B times A. So I multiply B times A using my calculator. Now, make sure you understand when I multiply this, you can use your calculator. I get this. Yeah, and everyone here knows how to do that, knows how to multiply these 2 matrices. But what do these values, what do they tell me? What's the significance of 1250, 1331 and quarter, $981 and a quarter? What does these mean? Okay, and I want you to write a complete sentence explaining what this means, what these values mean. Okay, so stop the video and write that down. Welcome back. Now, did you write something like each of these are the profits that both fruits yield per country? Something along that line. Then you would be right. So just know that you're going, obviously in big corporations and big companies, when they do this, they have thousands and thousands of data. So we're taking like a small little small little set here to explain what these values tell us. And companies, companies and corporations use it to see how they can maximize profit, minimize their costs using this method. Okay, so make sure you understand how to write this complete sentence. Okay, so again, I'm going to repeat what these values mean. These three values represent the profit each fruit produced from each country. Okay? All right. Have fun. Bye. Oh, and also, before I go, you should now be able to complete on page 577. Okay? Oh, today is the 8th, right? Sorry about that. Today is January 28th. Page 577, 82 and 83. And now you may go on to Schoology and check what you must do for 8.3. Okay? Good luck! Bye!